record. Okay, so what we got here is an AC parallel circuit. We're going to figure these out the same way we did when we did DC parallel. The only difference is everything has angles on it. So just like when we were doing AC series, we're going to follow the same steps. So I'm going to look, is my voltage in phasor voltage? Yes, it is. Okay, now I need to find X of C and X of L. Well, if you look at them, I already put them in ohms, so you know I've already gave you X of C and X of L. So if I put them in ohms, I'm already giving it to you. Next thing I'm going to do is I'm going to go by and I'm going to put angles on everything. My resistors always have an angle of
0.
0. My capacitors always have an angle of
Positive 90.
close, negative 90.
Negative 90.
And my inductors always have an angle of
Positive 90.
Positive 90.
positive 90. So now I'm ready to go. Here's where it's going to differ just a little bit from when we did DC parallel. We're still going to find Z total the same way we found R total. 1 over R1 plus 1 over C1 plus 1 over L1. The only difference is when I punch it in the calculator, Z total, I must put them all in parentheses. 1 k ohm at an angle is 0. Put it in parentheses, then hit shift reciprocal. Plus, parentheses again, 4 k ohm at an angle of negative 90. Close my parentheses, shift reciprocal, plus 2 k ohms at an angle of 90. All in parentheses, shift reciprocal equals, shift reciprocal equals, and that's my answer. Same way we did it. The reason I got to put them in parentheses is if I don't, I will only shift reciprocal my angle. And I do not want to just shift reciprocal my angle. I want to shift reciprocal everything. So if you forget to put them in parentheses, that will make a difference. Okay? You will definitely get the wrong Z total. So if I punch this all into my calculator, putting it in parentheses, you should get a Z total equal to, and I want everybody to punch it in the calculator, make sure you get this, 970.143 ohms at an angle of 14.036. So now, when we were in DC, what did we say about R total in a parallel circuit? It was always going to be what? Smaller than the smallest resistor, right? In AC, that is not necessarily going to be true because of the angle. Here, it works out it's smaller than the smallest component, but it won't always work out that way. Sometimes, depending on the values you have of all your resistors, or your resistor, your capacitor, your inductor, it might not be smaller than the smallest component. Okay? So there's really no way to look and go, yeah, hey, I'm definitely right. Or I'm pretty sure I'm right because it's smaller. Because it won't always be that way. Okay? A lot of times it is, but not always. It depends on all your values up here. Okay? And then once we get our Z total, we're going to find our I total. How do we find I total? We take our E total, we divide it by our Z total, and we're going to get I total, which on this one, if you guys do it, you should get 20.616 milliamps at an angle of 0.964. And then in parallel circuits, what were we finding? We're finding all the currents. So we're going to find IR1, IC1 and IL1. Well, how am I going to do it? What do I know about a parallel circuit? What's constant?
Voltage.
Voltage. So I know 20 volts at an angle of 15 is going to be my voltage drop here. 20 volts at an angle of 15 is going to be my voltage drop here. 20 volts at an angle of 15 is going to be my voltage drop here. Now I simply go back and use Ohm's law. Voltage divided by the impedance gives me the current through my resistor. Voltage divided by the impedance gives me my current through the capacitor. Voltage divided by the impedance gives me my current through my inductor. Okay. So if I do them for IR1, you should get 20 milliamps at an angle of 15. For IC1, you should get 5 milliamps at an angle of 105. And for IL1, 10 milliamps at an angle of negative 75.
Yeah, what
And
do
then
you
when
do
I
to,
say that again,
what do you do to calculate those again so I can get it in my notes?
voltage divided by the impedance gives me my current through my resistor. Voltage divided by impedance, current through my capacitor, voltage divided by impedance, current through my inductor.
Gotcha.
Just using Ohm's law. That's it. E divided by Z gives me I.
That makes sense. Thank you.
And then you just add these three together, and you should get 20.616 milliamps at an angle of 0.964. So when I did it, I actually added them all up, and what I got was 20.6155 milliamps at an angle of 0.963 in. And if I rounded that to 3 decimal places, I actually got 20.616 milliamps at an angle of 0.964. That's how I checked myself. Same way I did in series when I added up the voltages to make sure they equal my E total. Here I'm going to add up my current to make sure that it equals I total. Pretty simple. The hardest thing to remember is when I find Z total, I gotta put it in parentheses before I hit my shift reciprocal. A lot of people forget to put it in parentheses, and then you just shift reciprocal the angle, and that's not what we do.
For Z total or for I total, you do
E total divided by Z total. E total is going to be the same for everything because we know voltage is constant in parallel circuit. So it's going to kind of look maybe a little weird because E total is going to be the same for all of them because we know that it's constant, but it's still E total divided by Z total gives me I total. And then the individual voltage drop divided by the impedance of each component gives me the current for each component. Okay, so let's try one on your own. So I'm gonna see if you guys can get this. Like I said, these aren't super hard. It's just like we did in DC, but it's just now everything's AC, so everything has angles. We're
So
still
basically,
fixing.
both ways that you showed us is double checking itself.
Yes, because you always want to check it, make sure you're right. Don't just assume that you're right, because you know what they say when we assume, right?
Yep.
So we should always check yourself just to make sure. Make sure that it comes out to whatever your I total was. So I'll give you guys a few minutes and I want you to get Z total, I total, IR1, IC1, and IL1. So once you get all those values, I'll give you a couple of minutes to work on it, and then we'll go over the answers.
The angle I got.
Okay, so let's go. What did we get for Z total? That's going to be the key. Get this right, you're probably going to get everything else.
I got
So what-
24.702 ohms with an angle of 14.817.
And that is why you're on, because you're Z total.
What did I do wrong?
I got 1,059.998 ohms or 1.059 kilo ohms
I got that.
at an angle of 57.995.
That is correct.
Yes.
I didn't get that.
I don't know what I did with IT.
So for Z total, remember I told you got to put angles on everything. So we got a 0, we got a -90, we got a 90. And then I have to do what? I have to put them in parentheses, 2K, an angle of 0, shift reciprocal, plus, in parentheses, 5K, angle of -90, shift reciprocal, plus, parentheses, 1K, an angle of 90, shift reciprocal, then I hit equals, then I hit shift reciprocal again, and then hit equals, and I should get my answer. If you forget to put them in parentheses, that will make a difference. If you forget to put them in parentheses, it will only shift reciprocal the angle, and then you will get the wrong answer. So everybody punch it in the calculator just like this. It equals shift reciprocal equals, and you should get, if you round it properly, 1.06K at an angle of 57. Or you put 1.060. That's what I put. Then how do I find I total?
Bless you.
I take E total and I divide it by Z total. Does everybody remember how to save it in your calculator once you got your Z total? Remember you hit that little arrow and then alpha and Z and hit execute, and it saves your Z total in Z. Then all you gotta do is put 25 at an angle of 15 divided by alpha Z, and then hit equal. And it should give you your I total. Which if you get it, it's gonna probably give you 0.023585, blah, blah, bunch of numbers. So we're gonna move our decimal place and put it, and we're gonna get 23.585 milliamps at an angle of negative 42.995.
Yeah, getting that.
I know how I screwed up now. I did not include the angle with the 25 volts.
Ah, that definitely makes a difference. So you were basically saying it was 25 and an angle of 0.
I didn't get that.
You did not get that.
I didn't get it the first time, and even after you wrote it, I put it in there. I still didn't get that.
You didn't put it, what, Z total?
It's the total.
So when you put it in your calculator,
I put a quotation mark.
not quotation mark, but parentheses.
I mean parentheses. 2 exponent 3 angle of 0.
Close
And-
your parentheses. Did you close your
Yep.
parentheses?
I close it.
Then hit shift reciprocal.
If reciprocal
Plus,
plus
open parentheses again.
parentheses. Yep.
5 exponent 3 at an
Ang-
angle of negative 90.
correct? Close
close
parentheses,
parentheses, shift reciprocal,
plus,
plus, open parentheses,
uh-huh,
1K, 1 exponent 3
uh-huh.
at an angle of 90, close parentheses,
Oh, you know
shift
what I didn't do?
reciprocal
I didn't do that last shift reciprocal.
equals, and then I'm going to hit shift reciprocal one more time, and equals. And I got
That last one, I missed it.
on the inductor.
Yeah.
Ah,
Yeah.
so,
Hmm.
so that gave you, now when you got it, you should get 1.060 k ohms at an angle of 57.995. And then E total divided by that Z total should give me 23.585 milliamps at an angle of negative 42.995. So when I do IR1, did anybody get IR1 yet?
Yes.
What did you get?
I got 12.5 milliamps with an angle of 15.
Outstanding.
I do have a question on the next one, but I'll let
5
someone else answer.
milliamps at an angle of 15. Because all you're doing is, it's a parallel circuit. So my voltage drop across my resistor is going to be 25 volts at an angle of 15. Take that divided by 2K at an angle of 0. And you should get 12.5 milliamps at an angle of 15. For IC1, I know again, this is going to be 25 volts at an angle of 15 because it's a parallel circuit. Voltage is constant, so I just take that divided by 5K ohms at an angle of negative 90. And what did we get? Anybody?
I got one.
We get
Nobody
for
else?
IC1?
5 milliamps
5 milliamps
with an angle of 105.
at an angle of 105. Outstanding.
I do have
Okay.
one question.
Okay, what's your question?
On my calculator, it said 5 exponent negative 3. That means milliamps.
That's 5 milliamps. Yep.
Am I right? No.
And
Thank
then
you.
this one we know is still going to be 25 volts at an angle of 15. And then I'm just going to take that divided by 1 k ohm at an angle of 90. And I get anybody?
0.025. So 25 milliamps.
25 milliamps. And my angle is
90, I guess. It's not showing me an angle.
oh, did you put an angle in there? 25, angle 15, divided by 1K, angle 90.
Whoops. I put in the wrong.
Negative 75 should be your angle.
Yes.
So one easy way to tell, okay, when you divide these, it's going to be basically 15 minus 90 for your angle. If you multiply them, you're basically adding angles together. Okay? That's how you get. So here, you're taking 15 minus a minus 90, which means 15 plus 90. You get 105. Remember, when you divide it, it subtracts angles. When you multiply it, it adds. That's a, when there are easy ones like this, they're kind of easy to get when you're doing it this way. How we feeling? A little better?
Yeah.
See.
Not too hard, right? Doing parallel circuits. All you're doing is finding the current, and you're just using Ohm's law. Once you get Z total, just remember, anytime you do anything in parallel in AC, to get a Z total, you must put them in parentheses and put a shift reciprocal.
I still am not
Yeah.
getting I total correct at all.
Did you get this for your Z total?
Yes.
25 volts at an angle 15 divided by your Z total.
Okay, I got it.
Were you forgetting your angle on your voltage or something, maybe?
I did a Z total divided by the voltage instead of voltage divided by.
So you had it backwards. Yeah, it happens. We all do that every now and then. So do we want to do another parallel circuit? Or we think we're ready to move on to series parallel? You guys tell me what you want.
I'd rather move on, and if I need to review it, I'll review it in the video, but whatever.
That sound good to you? Everybody else?
Yep.
Okay, so we're going to move on and we're going to do a series parallel. Parallel ones, you guys should get those pretty easy. Series parallel, again, same thing that we did in DC. It's just now everything is in, everything has angles on it now. So we just got to figure it out a little bit different. I'm going to try to do one that's fairly short that I can redraw on this board, because as you guys know, limited space. So here I have a series parallel circuit, AC. Again, I'm going to do the same thing. Do I have my voltage in phasor form? Yes. Okay, I need to get my X of C and X of L. Well, they're in ohms, so I've already got them. So I just need to put angles on everything. I know angle on my inductor is always a positive 9. Angle on my capacitor is always a negative 9. Angle on my resistors is always 0. Okay. So now I'm going to do these the same way I did them in DC. I'm going to start at my source and I'm going to go farthest away from my source and look at what I have. Well, if I go farthest away, I've got these two components. Well, if I look at those two components, they're in what?
Series.
They're in series. So I'm just going to say 9.1 ohms at an angle of 0 plus 12 ohms at an angle of negative 90 equals. And I'm going to punch that in my calculator because that's how I find Z total in a series circuit. And when I do that, I should get 15.060 ohms at an angle of negative 52.826. And just like I did in DC, I'm going to circle it. And I'm going to redraw my circuit. Put my nifty little source in there. Put my inductor in there. 12 ohms, 90. Now, when I do these, I put these two together. Where do I put them? Well, I look. When I put these two together, they have 2 points in common with that inductor. So I'm going to put them in
parallel with it. But unlike DC circuits, instead of throwing a resistor, I'm going to put these in a box because I have more than one type of component. So I can't just make it a resistor, or I can't just make it a capacitor. So I'm going to put it in a box. And then I'm going to put my answer for my Z total in there, 15.060 ohms at an angle of negative 52.826. Well, what do I have now? Now I have a parallel circuit. So I can solve this. I can get my Z total. How do I do that? Put these both in parentheses before I hit my shift reciprocal because it's parallel. So I'm going to open my parentheses, put 12 ohms at an angle of 90, close my parentheses, shift reciprocal, plus open parentheses, 15.060 at an angle of negative 52.826, close my parentheses, shift reciprocal, equals shift reciprocal. And that's going to give me my Z total. And if I do that, I should get a Z total of 19.860 ohms at an angle of 37.17. Now I can get my I total. E total divided by Z total gives me I total. When I do that, I should get 3.021 amps at an angle of negative 37.173. I need this so when I check, so when I get my currents here, I can check, because in series parallel, what do? We get the voltage and the current for each component. Well, these are in parallel, so I know this is going to be 60 volts at an angle of 0 for my voltage drop. I know this voltage drop is going to be 60 volts at an angle of 0. So I'm going to take 60 volts at an angle of 0 and divide it by 12 ohms at an angle of 90. And when I do that, for this one, I get 5 amps at an angle of negative 90. So that's my current through my inductor. When I do this one, 60 at an angle of 0 divided by 15.060 at an angle of negative 52.6, I get 3.984 amps at an angle of 52.826. So that's my current through my combined components right there. I'm going to add these two currents up, make sure they give me my I total. If they do, this part of my circuit is good and I can move back. Well, I move back, I'm looking for what? The 15, what's in my box, it's circled, 15. How do I find it? These two in series. So what's constant in a series circuit? Anybody?
Amps.
Amps, the current. So this 3.984 amps at an angle of 52.826. This current comes back to both the resistor and the capacitor. So now, how do I get my voltage drop? I take my impedance, multiply it by my current. So when I do that, I get 36.254 volts at an angle of 52.826. That's my voltage drop through my resistor, across my resistor. How do I get the voltage drop across my capacitor? 12 ohms at an angle of negative 90 times my current. And when I do that, again, I'm running out of room, 47.808 volts at an angle of negative 37.174. And that's my voltage drop across my capacitor. I add these two up. What do they have to equal? Do they have to equal where they came from, where they come from? They came from here. What was my voltage drop here? 60 volts at an angle of 0. As long as that works, I'm done, because now I've got my current and my voltage drop across my inductor. I got my current and my voltage drop across my resistor, and I got my current and my voltage drop across my capacitor.
What does that top one say? 36.
36.254 at an angle of 52.826. I know I get going up there high, and it kind of gets a little blurry.
32.856.
At an angle of 52.826.
52.826.
26.
Trying to fix it. Thank you.
I regret saying that I'd like to go forward with this.
Well, this isn't any harder. It's just doing it the exact same way you did in DC. It's just everything has angles. So you got to put this in a box because we have multiple components that we're doing. It's not that hard.
I feel like
Simple.
it just looks like a lot because it's not
It-
as much
It
space.
does. It looks like a lot because because my board's all kind of small and crammed in there. But it looks like a lot because you got to put the angles on and do all that. And it just looks like your answers are bigger because you have the angles and stuff. So it makes it look like it's a lot more. But it's really not. You're doing the same thing we did in DC series parallel. We're starting farthest from the source. We're seeing what we got. They're in series, so we do Z total, just like we would in series. We just add them together. Then we put it in a box because I can't say it's one component or the other. And then I look at it. Here I made it easy. Once I got it, I had a simple parallel circuit. Because again, we're trying in series parallel. The only thing we know how to solve is series and parallel circuits. So I got to reduce it to where I get down to a simple AC series or a simple AC parallel circuit. Once I get to one of them, I know how to solve those. So let's do another one and we'll start. We'll go step by step. And I'll let you guys pick. You guys are going to tell me the answers, but we'll go step by step on how we're going to do it. Maybe that'll help you out if I let you guys figure out the answers. So, and not the same person giving me all the answers. Everybody's got to do it. Trying to write this as dark as I can so you guys can see it. Okay, so there we go. So we got an AC series parallel circuit. What's the first thing that I do? Every time I do an AC circuit, what's the first thing I do?
You Z total?
No.
You
Add the angle?
add the angles.
No, what's the first thing I do?
Put it in
I-
phasor?
I make sure my voltage is in phasor form. Because if it's not, I can't solve the circuit. So I'm going to look at my voltage and go, yep, that's phasor form, so I'm good to go. What's the next step I do?
Now you add the angles.
No, I got to find what? X of C and X of L. So I look, oh, wait a minute, these are in ohms. So I've already given you X of C and X of L, so I don't have to figure nothing out. Now what do I do, Dante?
Add the angles.
Now I add the angle.
Yeah.
So I go in and I know my resistors are always at an angle of 0. My capacitors are always at an angle of -90. And my inductors are always at an angle of 90. Okay, so now it's a series parallel circuit. So what do I got to do? Where do I start?
Right.
I go to my source, and then I go farthest away from my source. So if I go farthest away from my source, what I'm looking at is this 300 ohms at an angle of 90. I'm looking at my inductor. Well, is my inductor in series or parallel with another component?
Parallel.
It's in parallel with my capacitor. So how do I find it? I write it down. I got 200 ohms at an angle of -90 in parallel with 300 ohms at an angle of 90. So how do I find Z total in parallel? I got to put everything in parentheses before I do my shift reciprocal. So I got to put open parentheses, 200 ohms at an angle of -90, close parentheses, shift reciprocal, plus 300 at an angle of 90, well, open parentheses, 300 at an angle of 90, close parentheses, shift reciprocal, equals shift reciprocal equals. So somebody do that and tell me what you get for a Z total just for these two in parallel.
Can you go ahead and repeat that? I got all the way to shift reciprocal.
So you open parentheses, 200 at an angle of -90, close parentheses, shift reciprocal, plus open parentheses, 300 ohms at an angle of 90, close parentheses, shift reciprocal. Then I'm going to hit equals. Then I'm going to hit shift reciprocal again and hit equals.
I got 600 with an angle of -90.
Outstanding.
Ooh, cool, cool.
600 ohms at an angle of -9. And I'm going to circle that. Okay. Now I'm going to redraw my circuit. I'm going to put 10 volts at an angle of 0. I'm going to put my resistor in here. Where does this 600 ohms at an angle of -90 go?
In a box.
Well, if I smush this together, it goes where? In what with that 100 ohm?
Gosh, I know.
Is it?
It's going to go in series, right? And you were right. I'm going to put it in a box. I'm going to say this is 600 ohms at an angle of -90. And this was 100 ohms at an angle of 0. Well, now I have what?
Series.
I've got a simple series circuit. I know how to solve those. So I'm going to find my Z total, which is going to equal what? 100 ohms at an angle of 0 plus 600 ohms at an angle of -90. Because it's a series circuit, I just add them together.
Yeah, 700 ohms with an angle of -90.
Negative. Add them up and see what you get. You can't just add 160 and then add the angles. You got to actually punch it in the calculator.
I get 608.276.
608.276
At an angle of -80.
At an angle of -80.
0.538.
0.538. Outstanding. So that's my Z total. Now I can find my I total. Because how do I find I total? E total divided by Z total gives me I total. So somebody figure that out for me. Tell me what we get there. Was giggling, but they think they got the wrong answer.
Yeah.
But the last time you did that, you got the right answer.
Oh, must be milliamps then.
So what did you get?
6.439 milliamps.
You sure? 6 point?
No, 16. 16.
Ah, 16 point
0.439 milliamps
439 milliamps.
with an angle of 80.538.
Outstanding. So now I'm going to either use Ohm's law, I times Z, I times Z to get my voltage drop, or since it's a series circuit, I can use my voltage divider rule, whichever one you prefer. So somebody find me the voltage drop over the resistor.
You said
And
I times.
somebody find the voltage drop over the capacitor. Either I times Z, or my voltage divider, whichever you prefer to use.
So for 100 ohms,
Okay?
I got 1.644
1.644 volts.
volts with an angle of 80.537 or 537.
537, 538. Bingo, that's right. 1.664 volts at an angle of 80.537, 538, something like that.
1.644
Volts at an angle of 80.538 or 537, whatever you got. Whatever you had over here for your angle, that's going to be the angle because this one's a 0.
And that's basically IR1 that we just found.
That's the voltage drop across R1. It's VR1. Because we know what IR1 is, right? Because it's a series circuit. So I total is going to be my current through each component. So that was my voltage drop. Anybody get the voltage drop across the capacitor?
Why did you get 1.644 volts? I got 1643.9 with an angle of 80.537.
Okay, what did you punch in?
I punched in 16.439 with an angle of 80.537 multiplied by 100 with an angle of 0.
Because this is what? Milliamps. So it should have been 16.439 exponent -3. You left out your milliamps. You made it 16.439 amps.
Okay.
And that's how you got 164.39 milliamps. So I had to put that exponent -3 in.
Okay, thank you.
Yep. So anybody get me my voltage drop across my combination of components here, my box? Same way. I total times 600 at a -90, or my voltage divider rule, and I should get my voltage drop. Anybody?
9.863
Volts and an angle of
-9.463.
outstanding. So you should get 9.863, 864, somewhere around there, at an angle of -9.463, 462, 464, somewhere around there. depending on how you round it. Then I'm going to add these two voltage drops together and make sure I get what? 10 volts at an angle of 0 before I go any further, because I need to make sure that this circuit makes sense first. So if I add those up, you should get 10 volts at an angle of 0. So now I'm going to go back to, what did I circle? I circled this, my 600 at an angle of -90. Well, how did I find this? By these two in
Series.
parallel.
Mm.
So what's constant in a parallel circuit?
Voltage.
Voltage. So I'm going to bring this voltage drop of 9.863 volts at an angle of -9.463. I'm going to bring that back to my capacitor, and 9.863 volts at an angle of -9.463. I'm going to bring it back to my inductor as well. And now, what do I have to do? Now I have to find the current through my capacitor and the current through my inductor. How do I do that? Voltage drop across my capacitor divided by the impedance, which is 200 at an angle of -90, gives me my current. For the voltage, or I mean the current through the inductor, voltage drop across the inductor divided by the impedance, which is 300 at an angle of 90, gives me my current through my inductor. When I get these two currents, what must they equal? Where they came from here. What was my current here? 16.439 milliamps at an angle of 80.538. So when I get these two and I add them currents together, they should equal 16.439 milliamps at an angle of 80.538. So for my capacitor, I got 49.32 milliamps at an angle of 80.538. That's my current through my capacitor. And for my inductor, I got 32.88 milliamps at an angle of -99.462. And then when I add those up, I need to get 16.439 milliamps at an angle of 80.538. Because all I did was voltage divided by impedance, voltage divided by impedance. And that gave me my current. Don't worry, you're going to get some practice. I'm going to do up some problems and give them to you. And I might just take pictures because I'm getting tired of trying to, I don't have Visio on this. And I'm getting tired of trying to do it up in Excel. It's getting all crazy. So I might just take some pictures of my stuff out of the book and put them under your, I'll put them under your homework for you guys to do. I'll give you more of these than what I will give you of parallel, because parallel is pretty easy. Usually after you do 2 or 3 parallel circuits, you guys get parallel down. I'll give you more of the series parallel. Plus you can work on practice test 3A and 3B because they all have them. Matter of fact, do AC homework number 2, which is the one with the series circuits on. And then what I want you to do is do practice test 3A and 3B. That should give you plenty of practice. There should be plenty of circuits on every bracket before Monday. And then if you have any questions, we can go over what you have questions on. Series parallel, not too hard, just a pain like it was in DC, right? Not super
Tedious.
difficult. It's just, yeah, it's just tedious like it was in DC. Same thing. It's tedious. So there's only one thing left that you guys have to learn for the semester, and you will have all the knowledge that you need in order to complete the final test. So what I'm going to do is we're going to go over how to find the total capacitance if we have a circuit that has all capacitors. So if I have a circuit like this,
That's
and that's micro and micro, it's not milli. I know this one doesn't, that first one doesn't look very good, does it? Micro.
Are they both micro?
Yep, they're both micro. So what we need to understand here is I'm trying to find C total, okay? Just like I found R total, just like I found Z total. Well, now here I'm trying to find my C total. Well, I got to remember a few things. Capacitors in series act like resistors in parallel. So how did I find R total in a parallel circuit? R total is equal to 1 over R1 plus 1 over R2 plus dot, 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 however many I had, right? So C total if they're in series, C total is going to equal 1 over C1 plus 1 over C2 plus however many I have. So if I see capacitors in series, I'm immediately going to say, oh, bam, they act like resistors in parallel. So I'm going to figure them out like resistors in parallel. Now, do not get this confused where if I give you a AC series parallel circuit and I put two capacitors in parallel and I give you the X of C, do not do it like this. Do not think you're going to do it. I mean, you are going to do it like this, but don't think of it C1. There you're finding the Z total, not the C total, okay? Because I didn't give you the capacitor value. I gave you the, or if I put them in series, actually, not parallel. If I put them in series, don't think you're going to do it this way. There you're finding Z total, so they're in series. You just add them together. This is when I'm just have capacitors in a circuit, okay? So if I punch this in my calculator, I'm going to hit 3 exponent negative 6 shift reciprocal plus 3 exponent negative 6 shift reciprocal equals shift reciprocal equals, and I should get my C total. So somebody punch that in your calculator and tell me what we get for C total. Anybody get it?
1.5 e to the negative 0.6.
So that's what?
1.5 that's
Micro
there.
farads. That's -6 is micro. And I'm just doing capacitors. So it'll be 1.5 microfarad. I could have also did what? Well, we learned, did we not learn in parallel? If they're the same, all I have to do is take the value and divide it by how many I have. So I could have done it that way too. Because I only have 2, I could have said 3 microfarads divided by 2 leaves me with 1.5 microfarads. Because we learned that in doing resistors in parallel. If they're all the same, I just put down the value, divide by however many I have, and that's my total. So let's try another one. This one, you guys are going to have to do on your own. You guys figure out the C total, and then somebody tell me what you got once you get it. I'll be nice, and I'm going to leave that part up on the board for you guys so you remember. Dang it. I hate when I look at the wrong problem. So there you go. So you guys figure that one out. Tell me what you get for C total.
I get 2.97 micro Fs.
2.97 microfarads. Outstanding. That's all there is to finding if they're in series. Okay. So what if I have something like
Ooh. Never mind.
Ooh, what is that? Microfarads.
so now they're all in what?
Parallel.
Oh, in parallel. Well, guess what? If they were in series and they acted like resistors in parallel, guess what they do if they're in parallel?
They act like series.
Act like resistors in series. How do we find R total in a series circuit?
Adam.
So how are we going to find C total in a parallel circuit?
Adam.
Atom. So if I add those up, what do I get? Come on, really? You guys need a calculator for this?
9 microfarads?
Oh, wow. Look at that. 9.
Hey, you just said we can't just add
add-
them up. It would work
You
like
just
that.
add them up. If you can't add 3, 3, and 3 without a calculator.
No, I tried to add it up on the last thing we did.
Well,
You said I had
here-
to use
Here we can, because you were trying to add when we were finding Z total and you couldn't just add the numbers in the angle. That was different. Here we're just bam. So we get 9 microfarads. All right, let's try another one. Just to make sure you're You're getting it. And those are all microfarads.
27 microfarads.
See, look at this guy, man. He's on it. 27 microfarads. That's 20 plus 4 plus 2 plus 1 is 27. So, we're so good. Now I'm going to take all that away from you, because on the test, you're probably going to have something similar to this. And I'm going to say, find C total in this series parallel capacitive circuit. So what do? Same thing I've always done in series parallel. My source would be over here. I start farthest away. What do I have? Well, I got a 3 microfarad, a 2 microfarad, and a 6 microfarad all in series. So when I write it down, 3 microfarad, I'm going to say in parallel, because if they're in series, they act like resistors in parallel. That way I know I got to do shift reciprocal of everything. And if I do that out, what do I get? I punch that in my calc. Three exponent negative 6 shift reciprocal plus 2 exponent negative 6 shift reciprocal plus 6 exponent negative 6 shift reciprocal equals shift reciprocal equals. Anybody got it? Come on, somebody's got to have it by now.
1.2 microfarads.
Sure, you got 1.2.
I got 1 microfarad.
There you go. You come right out at 1. 1 microfarad. So where does this 1 microfarad go? Well, I squashed all those 3 together. So basically what's going to happen is these 2 would go away. And this one would become what? 1 microfarad, right? Because I just figured it out. What do I have now? Now I have a 3 microfarad, a 6 microfarad, and a 1 microfarad in parallel. How do I find C total in parallel? I just add them up, and what do I get?
10.
So my C total for that circuit was 10 microfarads. You'll probably get a problem like this on the test. I'll give you a series parallel capacitive circuit, and I'll just say, what's C total? So you just work your way down. If they're in parallel, add them up. If they're in series, do the shift reciprocal. That is all that you need to know for this class. So do your practice or your AC homework number 2, if you didn't do it already, and do as much of practice test 3A and 3B that you can get done by Monday. If you don't get both practice tests done, at least get one of them done and start working the second one. And then we will go over any questions that you guys have on anything that we have gone over in the class this semester.